Hey guys, welcome back. In the previous video we went over the Java3D API and we looked at some code examples. Now we've got a few more to look at in this part of the video. We've got the display effects, we've got the canvas demo, and we've got the Bouncy Ball project to look at. So let's start with the display effects. As you can see here, we have a ball that has a texture on it, and it also has a red light shining on it. Now here in the files you can see I've got the brick texture here, and it's a lot lighter. It doesn't have the red hue that it has here, and we'll explore why it has that. So in the display effects, again, we create our simple universe in our branch group. We create three colors. We create a black, a white, and a red. And here we're going to set up the path to find our texture. Now I'm setting up basically a relative path here. I create a new file and I use get absolute path. This is going to get the path to our project. And then I add on the images directory here because I've created a folder called images that contains our brick texture. So then I have system.out to make sure I've got the correct path. And then I create a texture loader. Now, if you remember from the PowerPoint, this is what's going to be used to load our texture into the program from a URL. So we add the local path plus the name of the asset. We're using RGB as opposed to luminance, which would create black and white, and a new container for it. Then we create our texture from the loader.getTexture. Then we have the set boundary mode, and the S and T are similar to U and V. It just means the X and Y coordinates on the texture. And we set these to wrap. So basically, if we reach the edge of the texture coordinate, it's going to wrap around and start tiling that texture. And then we set the boundary color. I'm not really sure what this does. I think it's if we go past the boundary and we don't have something like texture.wrap here, I think it just creates a solid color, but I'm not sure on that. We then set up our texture attributes, and the only thing we're going to do with that is we're going to set the texture mode to modulate. Now some other modes we can use as replace. We could use blend or we can use decal. And again, I'm not really sure what all these do, but if you are so inclined, you can look into that. Then we set up the appearance object, we set the texture, and we set the texture attributes for that. Then we set the material, and if you remember the material, it sets how light is reflected off of an object. And the parameters are ambient, emissive, diffuse, and specular light. And those colors we specified earlier, these are the colors that are going to be used for that. And we also have shininess, which is set to 1. Now, as I mentioned earlier, if we're applying textures to a primitive object, we need to set primitive flags. And so here we set primitive.generateNormals and primitive.generateTexture coordinates. Then we create our sphere, we add it to the group, and we create a white color, which will be for our directional light. We create the sphere of influence and the light direction. We set our directional light, and we add that to the group also. Then we're also going to create an ambient light, and this is just going to be a dull gray ambient light. It's just going to project a gray ambient light throughout the scene. And we set the influence bounds to the same bounds as the other light. And we add that light to the group. Then we set the viewing platform, and we add the branch group. And again, this is what happens. Now the reason it's showing up red is because of the material we set up. So see here, we're setting the ambient and the diffuse color to red. The emissive we're setting to black. Now what this is used for is if you have something like a neon sign that should emit a colored light, we'll set the color here. But because we're setting the ambient and the diffuse colors to red, it appears overall to be red. Now if I change those to white, and run it, now you see we've got our normal texture without any color changes on it. So you can see here how many different effects you can use to basically make colors and textures exactly what you want. So the last demo for this part of the tutorial is the canvas demo, and I'll run through this quickly. In the canvas demo, we're going to set the layout because remember this extends applet, so we have to set the parameters for the applet. We create the graphics configuration, which we get from Simple Universe. It's a static method, and this will just get the preferred graphics configuration that we'll use for our displaying our universe. Then we create the canvas, we add it to the center of the applet, we create our branch group with a simple color cube. Now this is going to have a similar output to the first tutorial with the red cube. The only difference is now we're going to be displaying it in a mainframe. So we create our simple universe, we pass it the canvas, set the viewing platform, and add the branch group. So back here in the main world, this has a few more lines of code. Here we're creating an object of that class, so we're going into the constructor, we're creating that. We're creating the mainframe and passing it that applet object, and then we're just setting the title here, and this is the result. You've got the same output as the original world, the first tutorial, but we just have it in a different window, an application. So the last tutorial, I'm going to close out of this project, and I'm going to open up the Bouncy Ball project. And it would help if I was in projects. This is just basically one class, and like I said, it pretty much implements everything that I've discussed here. It also implements action listener and key listener. Now these are going to be listening for keys, and you'll see why in a minute, and also actions. So here we have a bouncy ball simulator. When we click the start button, it starts bouncing. And you may notice it's jittering quite a bit. I believe that's because we don't have a back buffer. So basically every frame is being drawn directly to the canvas. And as you can see, the ball bounces up and down. When it reaches the bottom of the screen, it's scaled. You can see it contracts a bit, and it also moves around. So you can see how the transform is set. If I press the A and D keys, I can move the ball around. And that's about it. So we'll just take a quick look at the code here. We're creating a button here, which is our start button. We've got our transform group and our transform object. We've got the height of the ball, the sign, that will determine whether it's moving up or down, and the X location, which we edit when we press keys. So the main difference here is this: we're setting the transform group, and we're setting a parameter called set capability, and we're setting it to transform group that allow transform right. Now what this does is it allows us to change the transform after the object has been drawn. And this is what we need for any sort of game that requires objects to be moved based on input. Now here we've got the key pressed, and this is going to handle key events. When a key is pressed, we're looking for the A and D key, and we're going to move the ball over 0.1 each time one of those keys is pressed. Key released and key typed. We don't have an implementation for it. We have to define them because of the interface. Action performed. Now this is like our update. we created a timer object, which basically every tick is going to be updating our ball, and that code is here. So basically, we're looking for an action event. When we get one, if the source is the start button and the timer is not running, we're going to start the timer. And that's why, as you can see, when we run it, before we press the start key, nothing is happening because the timer hasn't started. That becomes like our update once we start the game or the simulation. And then after that, basically, if the source of the action is not the start button, it's going to be the timer tick. So we're going to modify the height of the ball, the sign if we need it to start moving in the opposite direction, and we're going to set the scale if we need to. And like I said, that's the ball contracting and expanding to simulate a bounce. And then we're going to set the translation and set the transform for the transform group. And that's about it. So guys, I hope you enjoyed this tutorial series. I think from here I might go on to create some beginner tutorials, just going over some basic principles of object-oriented programming. But if you enjoyed, like, comment, subscribe. So thanks, folks.